All right, section 3.3 is the first derivative test. Let's back up a second. Critical points tell us possible relative extrema. Right, and then we made a table of values, and just the highest value is the tallest, and the lowest value is the lowest, and that's kind of it. Well, the first derivative test is going to give us a way to figure out. Let's do it this way. So a table of values would give us the absolute extrema. The first derivative test, what we're going to learn today, will tell us if we have relative extrema. On the subject of reviewing, at critical points are f prime is 0 or undefined. So we've done the first step. We've done critical points. That was 3.1. Also part of 3.1 was doing a table of values to discover the absolute extrema. Today we're going to figure out or learn the first derivative test to figure out which ones are the relative extrema. So that's big picture what's going on today. F prime. A little bit more review here. What does the derivative tell you about the graph? Slope at a point. Slope at a point. But the slope also can tell you, and this is the big buzzword we'll use for the rest of the year, the slope tells you if f is increasing or decreasing. So if f prime is greater than 0, that means our slope is positive, and that means f is increasing. At least at that point. That might change later because we're not dealing with lines usually. But at least at this particular point, if f prime is greater than 0, that means the slope is positive. That means we're going up. F is increasing. Well, you could guess what the next line is going to be. If f prime is less than 0, that means the slope at that point is negative. Sorry, from your perspective, that's going down. Because we read a graph like we read a book, left to right, increasing, decreasing. That would mean f is decreasing. And if f prime equals 0, that means f is constant. At least for that moment. Right? Another way to phrase that is that we'd have a horizontal tangent line. All right, all of that's review. We know all of that. We hadn't maybe used these words before, but I think it makes sense. If the slope is positive, that means we're increasing. If the slope is negative, we're decreasing. If the slope is 0, we're at a point that's constant. It may not be constant for long, but we have a point that's constant. So there's not really new processes today. Like, we know how to do everything we need to do. We're just using it in a little bit different way. So we can jump in with examples and kind of learn on the fly. Let's find critical numbers. So that we know how to do. F prime is 0, F prime is undefined. There's a quiz question or two that's exactly that. Find the critical numbers for, so we know how to do that. And what we'll add today is increasing and decreasing intervals. So like, where is the thing increasing, where is the thing decreasing? If f of x equals 1/3 x cubed plus 2x squared minus 12x plus 3. All right, well, critical numbers, we said already, has to do with the first derivative. So let's take a derivative and see what happens. X squared plus 4x minus 12. It's like they rigged this problem to have a derivative we could deal with fairly easily. Critical points are where f prime is 0 or undefined as usual, not always, but usual, there's no place where that's undefined. Like, that's a polynomial, so there's no undefined points there. But we are concerned about where it's 0. So x plus 6 and x minus 2. So x equals -6 and x equals 2. Those are our critical points. So that's part 1 of our answer. X equals 6, x equals -2. Now I'm going to make a number line. -6 and 2. And I know f prime at those places is 0, but what I want to know is what's going on in between those places. What's going on at -6? What's happening at 0? What's happening at 3? So you pick any number in between, or any number on your interval. Obviously, you'd like to pick 0 if you can. Make sure you put it in the right spot. But any number on that interval will work for what we're going to test. And what we're going to test is the first derivative. Hence the first derivative test. So f prime of -7. Let's see. It might be easier to use the factored form rather than the polynomial form. You can use either one, but I don't want to have to mess with squaring 7 and multiplying by 4. I'm going to use the factored form. So -7 plus 6, -7 minus 2. And all I really care about is if it's positive or negative. So I've got a negative number times a negative number. That makes a positive number. So f prime at -7 is positive. If the derivative is positive, f prime is positive, that means f is increasing. So I can handle this a couple different ways. I can write f as increasing, or what a lot of people like to do is just to draw it increasing, because this is going to sort of mirror the graph. So when we get to graphing, if you're used to drawing a little up arrow, we have a rough picture of what the graph will look like. So on this interval, f is increasing because f prime is positive. All right, let's try f prime at 0. Again, I think the factored form is easier. Well, actually for 0, either form would be fine. So I got 0 plus 6 and 0 minus 2. So f prime on that interval is negative. So the derivative is negative. That means the slope is negative. That means f is decreasing. Then at 3, f prime at 3. Again, back to the factored form because I think that's easier. 3 plus 6, 3 minus 2. Everything's positive. That's nice. Easy. F prime is positive. That means f is increasing. All right, what was the point of this question? Increasing and decreasing intervals. So I'm going to write this as a table. I've got an interval. I've got 3 intervals. So I'll look at my number line. My first interval goes from negative infinity to negative 6, negative 6 to 2, 2 to infinity. The critical points set up the intervals. That's why it was so important to take a whole day to talk about critical points, because they're going to set up our intervals for today and going forward. Let's see, f prime, I already have all this information, I just have it in a different format here. F prime was positive, that means that f is increasing. Okay, don't get those backwards. F prime positive doesn't mean that f is positive, it means that f is increasing. Second interval, f prime was negative, almost wrote the wrong thing. If the derivative is negative, that means the function is decreasing. And then the last interval, the derivative is positive, so the slope is positive, so that means it's increasing. So that's the second part of the answer, the increasing and decreasing intervals. By the way, we started with a cubic. You generally know what the shape of a cubic looks like. Something like that, without putting any points on there. So it looks like it increases, and then it decreases, and then it increases. It increases, it decreases, it increases. It increases, it decreases, it increases. So some of these, this was kind of a question from earlier, like if you know the graph, it kind of makes sense with what we're doing. If you don't know the graph, then you just have to trust the calculus without the graph. But sometimes you know the graph and make it easier. All right, so here's the first derivative test written in words. We kind of used it already. Now let's make it official. If f prime changes from negative to positive at x equals c, f prime changes from negative to positive at x equals c, then f of c is a think about what that means. See if you can figure out what goes in those blanks. If f prime, I'm trying to fit my little picture there as well. F prime changes from negative to positive. So that would be like right here at x equals 2 for this problem. F prime changed from negative to positive. It went from decreasing to increasing. What does that mean that point is if it goes from decreasing to increasing at 2?
Relative extrema.
A relative extrema. Yes, be a little more specific though. A relative minimum. Right? This is something you don't memorize. Don't memorize that. Think about it. Because if f prime changes from negative to positive, then your picture just about explains what's going on there, it's a relative minimum. I'm almost out of space on this, but you know what the next one's going to be, I bet. If f prime changes from positive to negative at x equals c, f prime changes from positive to negative, from positive to negative, then what's going on at f of c? A relative maximum. And again, the idea is you don't memorize positive to negative means one, negative to positive means the other. Don't memorize. Think about it. Negative to positive means there's a minimum. Positive to negative means there's a maximum. And so you're just going to be thinking about that all year long. And in fact, I'll see people during tests occasionally kind of do one of those things, and that's fine. Okay, yeah, that's a minimum, maximum, whatever. Yes, sir.
Can you put a number for the interval, like putting it between the interval? Like you put 0 between -6.
What was that? So can I pick any number? Is that what
Can you pick any number between the interval?
you can pick any number on the interval. I just picked 0 because it was easy.
Yeah.
But you could have picked -5.5 if you wanted to. Bigger than 2, you could have picked 73. Any number on the interval will work. Because the only problem points are the critical points. There's no other critical numbers, so you're free to pick anything else. Alright, so the first derivative, I think, is not really a big deal. It makes sense if you understand what f prime tells you about a function. It tells you its slope. It tells you it's increasing or decreasing. So if it changes, you've either got a maximum or a minimum. Example 2. Find the relative extrema of f of x equals x squared minus 4 to the 2/3. Here's another one where we don't know what that graph looks like, so we can't do a quick sketch and check our answer against that. We're just going to have to trust the calculus. So to find relative extrema, we can find our critical points. That tells us our possible relative extrema. I left out relative because it also tells us the possible absolute extrema. Table would give us our absolute extrema. That's not really what we want. Our first derivative test, thinking about intervals, will tell us relative extrema. So they're sort of the roadmap for this problem. For this problem, we don't care about absolute extrema, so we're not going to do a table. We'll worry about doing the first derivative test. All right, so critical points are the derivative. Okay, so 2/3 times the thing to the -1/3 times the derivative. So chain rule, don't forget chain rule. So if I rearrange some things here, I'll have 4x in the top, and in the bottom I'll have 3. And the cube root of x squared minus 4. I think that's a little easier to look at. So f prime equals 0, because I'm thinking critical points. That would be where the top is 0. So that's an easy one. F prime undefined that would be where the bottom is 0. And here's a spot where some of you will work through the algebra. Some of you will look at that and just tell me the places where that makes that 0. And you can do either one. Does anybody know by looking what values of x would make this thing 0? Plus or minus 2. And so if you can look at that and jump to plus or minus 2, that's fine. If you need to do a little bit more work and say, well, let's divide by 3, and then cube both sides, and then move the 4 over, and then square root. But yeah, plus or minus 2. So I got 3 critical points that I need to be thinking about. So that means my number line surely nobody in calculus would make this error, but a favorite pre-cal error is to put the numbers on the number line not in numerical order. You can laugh at them, but don't make that mistake, or we will laugh at you. So make sure they're on in the right order. You can do the table first, or you can do fill out the intervals first, whichever. I'm going to set up the table. Interval f prime and f. So interval goes from -infinity to -2. I got 4 intervals this time. -2 to 0, 0 to 2, 2 to infinity. And so I need to test. I need to first derivative test to see if they're increasing or decreasing, because that'll tell me when it changes. I'll know if I have maximums or minimums. So again, you're welcome to test any numbers in between on those intervals, but I think those are the 4 best choices. And I will not entertain arguments otherwise on that one. Right? You can pick other things, but you're not going to pick anything better than those 4. Right, so f prime keep my work straight here. F prime, where did my F prime go? Way up there. So there's what I'm testing in. Looks terrible maybe, but I'm only concerned with positives and negatives. So I'm not real worried about the exact values of this. I'll show a little bit of work on the first one. So 4 times -3 over 3 times the cube root of 9 minus 4. But I don't really care about the values. I care about pluses and minuses. So that's negative over positive. So that's negative. That means my function is decreasing there, because f prime is negative. If I plug in -1, I'm going to get shorthand here. I'll get a negative in the top. The 3 doesn't really matter because it's positive, so I don't have to worry about it. The cube root of, better be careful here, 1 minus 4. So I don't have to worry about the details of that, but negative over negative is positive. So f prime is positive. That means f is increasing. I think I just found a minimum right there, but let's keep going. We'll figure that out at the end. I plug in 1, I get positive over cube root of -3. Positive over negative is negative. So f is decreasing. I should probably do a better job of labeling. So these arrows represent what f is doing. These things down here are what f prime is. Based on this pattern, I could guess what 3 is going to be, but let's plug it in and see. Cube root of 9 minus 4 is positive. Everything's positive. So it's increasing on that interval. Yes, ma'am.
So when we find vertical points, like, is it always going to change there, or sometimes are we going to find intervals that are like 2 positive?
Okay, great question. The question was, is it always going to switch, basically? Or are we going to find some that is like decreasing, decreasing? And the answer is there are some that are decreasing, decreasing. Or increasing, increasing. So generally speaking, especially for polynomials, they'll alternate. But there are some sneaky spots where they don't change. So you do have to test. You can't just like test one and alternate. You got to test them to make sure. All right, that's a lot of information. What question was asked? Find the relative extrema. Okay, well, there's a relative minimum at x equals. Where's my relative minimum at? Again, this is where the picture helps. So where's my first relative minimum? -2. Any other relative minimums? Yeah, at 2. And when you say that, you can't just, that's the right answer, but you have to give the reason. So because, and the reason is f prime changes. Again, I don't have it memorized. I'm looking at the picture or thinking about it. F prime changes from negative to positive. And there's a relative max at, again, if you want to loosely connect the points, your graph, you could, if that kind of helps see what's going on there. There looks to be a relative max at x equals 0 because f prime changes. The max happens. What we were looking for is positive to negative. Positive to negative. Oops. And you can write neg and pos, or you can do the signs plus and minus. Either one is fine. All right, so the assignment's page 183, 7 to 43 odd, 63 to 69 odd. I'm going to write this one more time. I don't know that you need to write this, but this little flow chart. Critical points give us our possible extrema. Then we can do a table of values to figure out who's the absolute max and min. That's 3.1. That's what's on the quiz. We can do intervals with the first derivative test to tell us who's the relative extrema. So, sort of this top branch is what's on the quiz. This bottom branch is not on the quiz. But it still uses some stuff that we've been doing. Yeah. All right, any questions on that?